Hello students, I hope you follow my previous class. So today our topic is isomerism in coordination compounds. So the word isomerism, it is actually a Greek word. The iso means same and meros. Meros means part, same part. So isomerism is same part. So what is isomerism? So at first we need to know what do you mean by isomerism. So isomerism, the two or more substances having the same molecular formula, but they have different structural as well as spatial arrangement are known as isomers. So either two or more than two compounds which have same molecular formula. So two or more compounds have the same molecular formula, but only difference is either structural difference or spatial difference, spatial arrangement of their ligands. So if their structures are different or the ligands within the structure is differently arranged, then those types of substances are known as isomers, and this phenomenon is called isomerism. So what is isomerism? The two or more substances having the same composition or same molecular formula, but different in their structural and spatial arrangements are called isomers, and this phenomenon is known as isomerism. The coordination compounds shows mainly two types of isomerism. The coordination compounds shows mainly two types of isomerism. So what are the two types? One is structural isomers, another is stereoisomers. The two types of isomerism are: number one, structural. Structural isomerism, and number two, stereoisomerism. So stereoisomerism, it is also called space isomerism. So stereo or space isomerism. So structural isomerism and stereo or space isomerism. So now one by one. So at first we are going to structural isomerism. So what is structural isomerism? The two or more substances which have the same molecular formula but difference in their structures are called structural isomers, and this phenomenon is called structural isomerism. So this type of isomerism arises due to the difference of structures although they have the same composition. So structural isomerism is further classified into four types. So it is again four types. Structural isomerisms are classified into four types. So what are the four types? Say number A, first type is ionization isomerism. Number two, Sulfate or Hydrate Isomerism. Number three, Linkage Isomerism. And number four, Coordination Isomerism. So at first, Ionization Isomerism. What is Ionization Isomerism? What is ionization isomerism? The compounds which give different ions in solution, although they have the same composition are known as ionization isomers. So example, say first example, CO NH3 Cl or Br SO4, and similarly CO NH3 SO4 Br. So you see, both the compounds have same composition. CO is the central atom, 5 NH3 molecule, so 5 amine 11 Br 11 SO4. So they have the same composition, but they give different ions in solution. So this compound gives sulfate ions in solution, and it is a red violet color, and it is a red colored compound. So this compound gives sulfate ion when treated with barium chloride, and this compound gives bromide ion when treated with AgNO3. But if it treated with barium chloride, then it does not give sulfate ion. So these two compounds have the same composition, but they give different ions in solution. Similarly, another example, number 2, Cr and Cr H2O4 Br2 Cl2. So this compound gives bromide ion in solution when treated with AgNO3 solution. This compound also gives chloride ion in solution when treated with AgNO3 solution. See, in both the compound, in solution, this complex part, the complex part does not lose its identity in the solution, whereas counter ion can be dissociated in the solution. That's why this compound gives bromide ion and this compound gives chloride ion in solution. So both the compounds have the same molecular formula or same composition, but they give different ions in solution. That's why these are ionization isomers. Secondly, number B, solvate or hydrate isomerism. Solvate or hydrate isomerism. So what are solvate or hydrate isomerism? So two or more compounds which have the same composition but differ only in the number of solvent molecules present as ligand. The present as ligand means the solvent molecule must be enclosed in square bracket, that is coordination sphere. So the compounds which have the same composition but differ only in the number of solvent molecule present as ligand and as free solvent ions in the crystal lattice is known as solvate isomer. The compounds which have the same composition but differ only in the number of solvent molecules present as ligand or as free solvent molecules in the crystal lattice is known as solvate isomers. And if water is the solvent molecule, then they are called hydrate isomers. For example, number 1, see Cr, chromium is the central atom. So Cr H2O6 Cl3. So here chromium central atom and here solvent molecule is water. So 6 H2O molecule present as ligand. Chromium H2O5 Cl Cl2 dot H2O. So one chlorine enter here and one H2O comes outside. So coordination number 6. So both the compound have the same formula, but the number of solvent molecule present as ligand is different. Here 6 solvent molecule, water molecule present as ligand. Here 5 water molecule present as ligand and 1 H2O molecule as counter ion. Its color is blue green. It can also give Cr H2O4 Cl2 Cl dot twice H2O, twice H2O. It is dark green. So they are solvate isomers, and since water is present as ligand and free solvent molecule, that's why they are also called hydrate isomers. Another example, so CO NH3 H2O Cl. And CO NH3 Cl2 Cl dot H2O. So in this compound, cobalt central atom, 4 NH3, 1 H2O and 1 Cl. 4, 5, 6, coordination number is 6. Here see 4, 2, 6, coordination number 6. Central atom is cobalt. So in this compound, 1 H2O molecule, 4 NH3 solvent molecule, 1 H2O solvent molecule present as ligand. But here 4 NH3 only present as ligand. H2O is free solvent molecule. But although both the compound have the same molecular formula. So these are solvate or hydrate isomers. तो हो गया हम लोगों का आयोनाइजेशन आइसोमर्स, सॉल्वेट और हाइड्रेट आइसोमर्स. थर्ड टाइप इज लिंकेज आइसोमरिज्म. तो नंबर सी, लिंकेज आइसोमरिज्म. तो व्हाट इज लिंकेज आइसोमरिज्म? तो दिस टाइप ऑफ आइसोमरिज्म arises if the coordination compound contains one ambidentate ligand containing more than one donor atom. So this type of isomerism arises due to the presence of ambidentate ligand which contains more than one donor atom. For example, so first example, Cr NH3 ONO Cl2 and Cr NH3 NO2 Cl2. So in both the compound they have same central metal atom NH3 ONO and NO2. So ONO nitrato group, NO2 nitro group. So it is ambidentate ligand. Here nitrogen atom donates its lone pair of electron to the central atom chromium, and here oxygen atom donates its lone pair of electron to the central atom chromium. So since in this compound one ambidentate ligand is present which contains more than one donor atom, so this kind of isomers are known as linkage isomers. Another example, number 2, cobalt H2O5 SCl. SCl, thiocyanate and CO H2O5 NCS tripositive. So here thiocyanate, isothiocyanate. So these are ambidentate ligand. Ambidentate ligand is present, so it is linkage isomers. And number D, coordination. Coordination isomerism. So what is coordination isomers? So this type of isomerism occurs only in those compounds which contains both cationic and anionic complexes. So coordination isomerism occurs in those compounds which contains both cationic and anionic complexes. For example, number 1, Cu NH3 PT Cl4. The first part is cation, second part is anion. So this compound contains both cationic and anionic part. Similar, and its isomer is platinum NH3 Cu Cl4. So you see, both the compounds have the same molecular formula. Here copper 4 NH3 amine के साथ attached है, and platinum 4 chlorido group के साथ attached है, chlorido ligand के साथ attached है. Here platinum is attached with amine ligand, whereas copper is attached with chlorido ligand. Another example, CO NH36 Cr CN6 and Cr NH36 CO CN6. तो here you can say only just central atom को change कर दिया, बाकी सब कुछ same. The coordination isomers occurs only in those compounds which contain both cationic and anionic complexes. Clear? So structural isomerism is over. The structural isomerism occurs only in those compounds which gives different structures. So structural isomers are classified into 4 types. Number 1, the ionization isomers, very important. Then sulfate or hydrate isomers, linkage isomers, and coordination isomers. So structural isomerism is over. Now stereo or space isomerism. Stereo or space isomerism. So what is stereo or space isomerism? Number 2. Stereo or space isomerism. So now stereo or space isomerism. This type of isomerism arises on account of the different positions and arrangement of ligands in space around the central metal ion. So different positions and arrangement of ligands in space around the central metal ion, stereo or space isomerism arises. So this type of isomerism is further classified into 2 types. So it is again 2 types. It is further 2 types. number A, geometrical isomerism, or it is also called cis-trans isomerism. So geometrical isomerism or cis-trans isomerism. And number B, optical isomerism. So geometrical isomerism and optical isomerism. So now one by one. Number A, geometrical isomerism. Or cis-trans isomerism. So this type of isomerism do not show by those compounds which have coordination number 2 and 3. So with coordination number 2 and 3, the complexes does not show geometrical isomers. Again, the tetrahedral complexes with coordination number 4 also cannot show geometrical isomers, because in tetrahedral complexes, see this is the tetrahedral complex, central atom. So in tetrahedral complex, all the 4 positions are equivalent. That's why tetrahedral complex also cannot show cis-trans isomers. But the square planar complexes with coordination number 4 and octahedral complexes with coordination number 6 can show geometrical or cis-trans isomers. So let's see. So number A, square planar. Complex. तो स्क्वायर प्लेनर कॉम्प्लेक्सेस. तो स्क्वायर प्लेनर कॉम्प्लेक्स में कोऑर्डिनेशन नंबर कितना होता है? कोऑर्डिनेशन नंबर 4. तो इन स्क्वायर प्लेनर कॉम्प्लेक्स से फर्स्ट टाइप नंबर 1, M A2 B2 टाइप. तो M A2 B2 type. So here M is the central atom, A and B, these are ligands. So M A2 B2 type. Say example, PT NH3 2 Cl2. Say another example, palladium Cl2 Py2. So M A2B2, M A2B2. So this type of compound are square planar compound. So square planar complex structure, see. So we are taking this one. Platinum is the central atom. 1, 2, 3, 4 coordinate bond. NH3. NH3. So NH3 2, Cl2. So now see, in this plane, both the NH3 are in the same plane. Both Cl ligands are in the same plane. तो same plane में होने से these are cis isomers. Cis isomers. Similarly, platinum central atom is platinum. So NH3, they change their position. This chlorine comes over here and this NH3 comes down here. This chlorine same. So now see, if you mark one line here, then both the NH3 are in the opposite plane. Both the Cl ligands are in the opposite plane. Opposite plane में होने से these are trans isomers. So M(A2)B2 type compound, which are square planar compound because their coordination number is 4. So this type of compound gives geometrical isomers or cis trans isomers. Number 2, M(A2)BC type. So M(A2)BC type compound, for example, CO NH3 M(A2)BC, so ClBr. Some other example, PtCl NO2 Py2. So M(A2)BC type. So this compound, so cobalt is the central atom, coordination number 4, NH3 ClBr. So both the NH3, these are two different ligands. So both NH3 ligands are in the same plane. So this is cis isomer, and its transform is CO. You change this to NH3, Cl यहाँ पे आ गया, NH3 यहाँ पे आया, and Br is same. तो क्लोरीन और ब्रोमीन चेंज होने से भी पता नहीं चलेगा because these are two different ligands. But here you see NH3. So both the NH3 are in the opposite plane. Same plane में NH3 नहीं है. So this is trans isomer. तो M(A2)BC CONH3 ClBr, CONH3 ClBr shows two structures. So these are cis and trans isomers, that is geometrical isomers. Number 3, M(AB2) type. So AB2, so AB, so this is a didentate ligand which contain two different donor atom. Example, PtGly2, PtGly2. So here, where Gly, so Gly, this is glycinate ion, and glycinate ion का formula NH2 CH2 COO negative. So nitrogen contains lone pair. Here this oxygen contains lone pair of electron. So nitrogen can donate its lone pair of electron and form one coordinate bond. Similarly, oxygen can donate one lone pair of electron to the central atom and forms coordinate bond. So platinum glycinate 2, its structure is like this. The central atom platinum is attached to it, glycinate ion. So NH2 CH2 C double bond O, single bond O, C double O. So NH2 CH2 C double O. So NH2, its lone pair of electron forms this coordinate bond. Oxygen forms one coordinate bond with platinum. Similarly, NH2, this is one glycinate ion, glycinate is 2, CH2 C double bond O, O. So this is cis. Why cis? Because both the NH2 in the same plane. Both oxygen ion in the same plane. So this is cis. Then the name of this compound is glycinate ion is a didentate ligand. So cis, its common name is diglycinato. So the name of this compound is cis diglycinato platinum 2. So glycinate ion contains 1 negative. So 2 glycinate ion, 2 negative. So -2 is a +2. So cis diglycinato platinum 2. Similarly, its transform is platinum central atom NH2 CH2 C double bond O, single bond O. Now NH2 starts with this position. NH2 CH2 C double bond O, coordinate bond, another oxygen. So here both the nitrogen in the opposite plane, both the oxygen in the opposite plane. So it is trans isomer. So trans diglycinato platinum 2. Diglycinato platinum 2. So clear? It is MAB2 type. So at first MA2B2 type, number 2 MA2BC type, number 3 MAB2 type, and number 4 MABCD type. Number 4 MABCD type. So see, here M is the central atom, A, B, C, D, all are 4 different ligands and each are monodentate ligand, MABCD type. The example, say platinum is the central atom, PT, NH3, Br, Cl, NH2, OH. So in this compound there are 4 different monodentate ligands. So MABCD type compound gives 3 isomers. So this kind of compound can give 3 isomers. Out of the 3 isomers, 2 are cis form and 1 is trans form. And the structure of this type of compound can be shown by fixing the position of one ligand. तो एक ligand का position fix रख के the isomers can be drawn. For example, you see, say platinum NH3 Br Cl NH2 OH. This is one ligand, this is one complex. Similarly, platinum. Now fixed the position of any one ligand. So this position is fixed, NH2OH. This position is fixed. So it is fixed position. Now we can change the positions of these two ligand. तो NH3 के प्लेस में आ जाएगा ब्रोमीन और NH3 यहाँ पे. This is same. Similarly, another platinum, so NH2OH, this position is fixed. So we already changed these two positions. Now these two positions, तो chlorine यहाँ पे, bromine यहाँ पे, chlorine यहाँ पे, bromine यहाँ पे, and NH3 remains same. So in this three complexes or three isomers, you see, if you consider NN, same plane, this is cis, NN, opposite plane, this is trans, NN, same plane, cis. So two of the isomers are cis form and one is trans form. If you consider NH3 and bromine in the same plane, so this is cis, NH3 and bromine same plane, cis, NH3 and bromine opposite plane, trans. So in this type of ABCD type of complexes, it gives three isomers, out of which two are cis and one is trans. So square planar complex with coordination number 4 give these four types of isomers: Ma2B2 type, Ma2BC type, MAB2 type, and MABCD type. So square planar complexes are over. Now octahedral complex. So number B, octahedral complexes. तो octahedral complex में coordination number कितना होता है? Coordination number 6. In octahedral complexes with coordination number 6. So in octahedral complex, first type Ma4B2, or we can write Ma2B4 type. Ma4B2 or Ma2B4 type. The example of this type of compound, say CO, NH3 Cl2 positive, M central metal atom or ion A4B2, or we can write Cr NH3 so Br2 positive. So Ma4B2, Ma2B4, you can say this. So this type of compounds have structure. So since it is octahedral complex, so I am taking this example. Cobalt is the central atom. 1, 2, 3, 4, and then 5, 6. Coordination number is 6. NH3 NH3, 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 NH3 4, and Cl2, 1 chlorine, 1 chlorine. So in this structure, both the chlorine in the same plane. So this is cis isomer. Similarly, here cobalt central atom 1, 2, 3, 4, 5, 6. Now chlorine, and this chlorine comes here in the opposite plane, and all NH3, 2, 3, 4 NH3. So chlorine in the opposite plane, so it is trans isomer, MA4B2 type. Next, now number 2, M AA2 B2 or M AA2 BC type. So AA is didentate ligand which have same donor atom. AA is the didentate ligand with same donor atom. So B2 or BC. Example, say CO EN2 हो गया EE2, B2 से you can write Cl2 positive और Cr En2 Cl Br positive. Its drawing is like this. CO En2 तो ethylene diamine. तो structure of ethylene diamine is CH2 CH2 NH2 NH2. This is ethylene diamine. So this nitrogen and this nitrogen donates their lone pair of electron. So we can write NH2 CH2 CH2 NH2. So its coordination number is 6. Here it is 4, 5, 6. So ethylene diamine we can write like this, or simply we can write in this 2 position ethylene diamine. Similarly in these 2 positions ethylene diamine in these 2 positions, and 2 chlorine Cl Cl. So 2 chlorine in the same plane, so this is cis isomer. Similarly trans isomer, cobalt central atom 1 2 3 4 5 6, En2 say En in this 2 position 1 En, and in this 2 position this position and this position another En, and both the chlorine in the opposite plane. So this is trans isomer MAA2 B2 और BC chlorine Br Cl Br ऐसा भी हो सकता है. So these are trans isomer. Number 3, M A3 B3 type. M A3 B3 type. So for example, RH Cl3 Py3. RH rhodium is the central atom. Similarly, CO NH3 3 Cl3. So M A3 B3 type. So M A3 B3 type is the structure. Say RH rhodium 2 3 4 5 6. Cl3 chlorine chlorine chlorine, Py pyridine pyridine pyridine. So this is cis isomer. And here you see the plane of this 3 chlorine. This 3 chlorine this part is facial isomer. This part is facial isomer. So it is cis isomer, or it is also fact isomer. Fact means facial. Similarly, rhodium central atom 5, 6, coordination number. Cl3. Now here, these two changes their position. So Cl here and Py here. These two changes their position. Py, Cl, chlorine, Py. So here chlorine is the same plane. In the same plane chlorine, same plane Py. These are cis isomer. And this part is facial part. That's why it is also called fact isomer. Here you see chlorine in this part, chlorine in this part, opposite part. Py first part, second part. So these are trans isomer. Trans isomer. Here this plane, chlorine, chlorine, chlorine. This plane is meridional plane. That's why this type of isomer is also called Mar isomer. Mar isomer. Here fact. Fact represents facial. Facial isomer. Mar. Mar represents meridional. So facial isomer and meridional isomer. This is very important. A3B3 type compound can give only facial and meridional isomers. That is cis and trans isomers. Number 4. Octahedral complexes with M, A, B, C, D, E, F type. So octahedral complexes of the type M, A, B, C, D, E, F, that means 6 different monodentate ligands, can give 15 different isomers. So this kind of compound can give 15 different isomers. So one example of this type of compound is platinum, central atom, NH3, Br, Cl, I, NO2, Py. So this compound contains 1, 2, 3, 4, 5, 6 different isomers. So the octahedral complex, which contains 6 different monodentate ligands, can give 15 different isomers. Again, number 5, octahedral complex with M, A6 and M, A5B. M, A6 and M, A5B would not show any geometrical or cis-trans isomers because all the positions are, that means all the ligands in all positions almost same. That's why they cannot show any geometrical isomers. But if the compound contains didentate chelating ligands, then it can show geometrical isomers. That is M, say AB3. So MAB3 type compound can show geometrical or cis-trans isomers. So up to 4, it gives 15 isomers. First type was Ma2B4 or A4B2. Ma2B4 or Ma4B2 type compound can give geometrical isomers. MAA2, that is identity ligand. MAA2BC or MAA2B2 type compound gives geometrical isomers. Number 3, Ma3B3 type compound gives geometrical isomers or cis-trans isomers or Planar isomers. Number 4, MABCDEF, that means 6 different monodentate ligands can give 15 different isomers. But MA6 or MA5B type of compound would not show any geometrical isomers. Whereas if the octahedral complex contains didentate AB type ligands, then it can show geometrical isomers also. So geometrical isomer is over. Now optical isomerism. So now we are going to start with optical isomerism. So optical isomerism. What is optical isomerism? So an optical active substance is that which can exhibit such two structures which are non-superimposable mirror images of each other. So if any substance gives non-superimposable mirror image, then that substance is known as optical active substance. Say if I placed my hand like this in front of a mirror, then the mirror image comes out to be like this. Now see, say there is one ligand. So this ligand and this ligand, you can see in the same side. This ligand, you can see in the same side. Then it is not non-superimposable mirror image. It will be superimposable mirror image. और superimposable होने से the substance is not optically active. The substance should be optically inactive. But superimposable mirror image कैसा है? अगर ऐसा place किया mirror के सामने, or you can see the structure like this. Say if I put my marker like this in front of a mirror, then you will see this structure like this. Okay, so this part is right side and this part is left side, and here I can see this part in the left side, whereas this part in the right side. So if the structures are non-superimposable, then only the substance will be optical active. The optically active substance should not contain any plane of symmetry. So the coordination compounds with coordination number 4 and 6 can only show optical isomerism. So at first, number A, coordination number 4. So with coordination number 4, there are square planar complex and tetrahedral complex. The first, square planar complex do not show optical activity. So this is square planar complex. Say any central atom, X is the central atom, square planar complex. So in square planar complex, it has plane of symmetry. That's why square planar complex do not show optical isomerism. Number 2, tetrahedral complex. So central atom X, 1, 2, 3, 4. So tetrahedral complex with 4 different ligands also do not show optical activity. Number 3, only tetrahedral complexes with unsymmetrical bidentate ligand. If the tetrahedral complex contains unsymmetrical bidentate ligand, like glycinate ion. So unsymmetrical bidentate ligand होने से it can show only optical isomerism. So tetrahedral complexes containing unsymmetrical bidentate ligand can show optical isomerism. So this is not so important. We are going to with coordination number 6, that is octahedral complexes. Number B, coordination number 6. So coordination number 6, that means octahedral complexes. So here first example is MAA3 type. So MAA3 type compound. For example, COEN3 positive, CrOX3 negative. So this kind of compound can show optical activity or optical isomerism. See, COEN3. So En is a bidentate ligand. So 2 into 3, 6. The coordination number is 6. The coordination number 6 होने से CO 1, 2, 3, 4, 5 and 6 coordination number. EN3. So there is one EN. In this 2 position there is one EN. In this 2 position there is another EN. Now if we placed this in front of a mirror, this is a mirror, this one is mirror, then the mirror image will be like this. CO this EN comes out here. This EN comes out here. This EN goes towards in this direction. Okay. Now see, both the structures are different structures. Here EN, this EN is the left hand side, but here left hand side there is no EN. It is right hand side. This EN is present in right hand side. So these two structures are different structure. So this type of structures are called non-superimposable mirror images. Or non-superimposable mirror image होने से they are optically active. So for optical isomers, it is written dextro or D, and it will be levo or L only. D and L, dextro and levo. Geometrical isomers, it was written cis and trans, and for optical isomers, dextro and levo. Dextro, then name of this compound, levo, name of this compound. So MAA3 type first. Next, number 2, MAA2 B2, or we can write MAA2 BC type. MAA2 B2 or MAA2 BC type. For example, CO EN2 Cl2 positive. तो MAA2 B2 और ClBr भी लिख सकता हूँ BC type. So for this type, the structure is the central atom covered En2. In this position, one En. In this 2 position, there is another En. Cl, Cl. So MAA2B2 type compound can also give geometrical isomers. So this is the cis product. Both the Cl in the same plane. But if both the Cl will be in opposite plane, it will be trans product. So this compound in front of a mirror gives the structure CO 1, 2, 3, 4, 5, 6. So this chlorine comes here, this chlorine here, this En group here, and this En goes towards in this direction. Okay, so this is the cis form, and here it is dextro and it is levo, dextro and levo. It is also the cis CO En2 Cl2 form. But if I draw the transform, see the transform here, so transform होगा CO 1, 2, 3, 4, 5, 6. Now see, here one mistake. This is total positive charge. You have to give here like this, positive, positive. Similarly, to transform होने से one chlorine here, another chlorine here, and in this 2 position En, and in this 2 position another ethylene diamine. Now if it is the mirror, our structure will be like this. CO 1, 2, 3, 4, 5, 6. This En comes here, this chlorine here, this En goes towards this direction, this chlorine here. So this is positive charge, CO En2 Cl2 positive. Positive. Now see, both the compound looks like same. So these are superimposable mirror image. And if the compound gives superimposable mirror image, this is superimposable mirror image. Superimposable mirror image होने से the compound is optically inactive. So they are not optical isomers. It is optically inactive. But here these are non-superimposable mirror image, and non-superimposable mirror image is optically active. They are optically active. So they are optical isomers, whereas these are not optical isomers. So MAA2B2 or MAA2BC type of compound can show optical isomers, only by its cis form, not the trans form. Next, number 3, M AA B2 C2 type. फॉर एग्जाम्पल, तो सेंट्रल एटम उसके साथ एक डाइडेंटेड लिगैंड B2C2. तो एग्जाम्पल इज COEN B2, that is NH3 2, so Cl2 positive. So this is NAA B2 C2 type compound. Its structure CO central atom, EN ethylene diamine. So here it is ethylene diamine. NH3 2, so NH3 NH3, Cl2, so one Cl, second Cl, positive. So if it is placed in front of a mirror, then its mirror image will be like this. CO central atom, 1, 2, 3, 4, 5 and 6. So this chlorine comes over here, this chlorine, the chlorine, this NH3 in this position, this NH3 in this position, EN ethylene diamine is in this position. It is also positively charged. So this is dextro and this is levo. Here you see both the compounds are different. So it is non-superimposable mirror images, and that's why they are optical isomers. Number 4, the octahedral complexes containing hexadentate ligand. The hexadentate ligand, say EDTA. EDTA is a hexadentate ligand. So one example, I am writing octahedral complexes containing hexadentate ligand. For example, CO EDTA. So EDTA, ethylene diamine tetraacetate ion, negative. Also shows optical isomerism. The octahedral complexes which contains hexadentate ligand can also show optical isomerism. Clear? So isomerism is complete. So in isomerism, coordination compound shows two types of isomerism. One is structural isomerism, another is stereo or space isomerism. The structural isomerism is further classified into 4 types: ionization isomerism, Sulfate or Hydrate Isomerism, number 3 Linkage Isomerism, and number 4 Coordination Isomerism. Then stereo or space isomerism is further classified into 2 types. One is geometrical or cis-trans isomerism, another is optical isomerism. तो geometrical isomers में the coordination compounds which have coordination number 2 and 3 cannot show geometrical isomers. And coordination number 4, तो coordination number 4 होने से square planar complex भी होता है, tetrahedral complex भी होता है. But tetrahedral complex having coordination number 4 do not show geometrical isomers because all 4 positions are equivalent. But square planar complexes can show geometrical or cis-trans isomers. And also octahedral complex with coordination number 6 can show geometrical isomers. And in optical isomerism with coordination number 4 and coordination number 6 can show optical isomerism. तो with coordination number 4, तो coordination number 4 के साथ square planar and tetrahedral complex. तो square planar complex have plane of symmetry. That's why they do not show optical isomerism. Tetrahedral complexes, if it contains all the 4 different ligands, also cannot show optical isomers. But if the tetrahedral complex contain unsymmetrical bidentate ligand, then it can show optical isomer. And octahedral complexes with type MAA3, MAA2B2 or MAA2BC, MAAB2C2 type can show optical isomers. And also the octahedral complex having hexadentate ligand, that is COEDTA negative, can also show optical isomers. So isomerism is over. Thank you.